Okay, I just need to pull it up. So homework. All right, so this is done. Which part?
Part 2, column 6.
Okay, and I have, this is part 3. I need, this is what? Part 3. Part 2. Problem 6. This is the index of refraction. Okay, thin film.
Yep.
So what's your first step for this problem?
So what I did was I drew a diagram of the situation. So there's
How many boundaries in your diagram?
There's 2 different boundaries from air to.
So please please read me your index number 1, number 2, number 3.
Yep. So the index number 1 is just 1 because it's air. Index number 2, it was 1.38. And the next index was 1.6.
Oh, okay. Same. And okay. So what do you have for your phase shifts? At the top,
So,
at the bottom?
So like from the first, like when it goes from air to, what's it called, MGF2, isn't there a phase shift of 180? Because the index.
Yeah, but in terms, we need the phase shift in terms of the wavelength. The effective path length difference is equal to 2t plus this.
Yeah. Oh, yeah.
And we need these variables in terms of the wavelength. You cannot use thickness, which is millimeters or nanometers, and degrees.
Oh, yes. Okay.
The phase shift does happen. It flips by 180 degrees, correct? But it is an equivalent of a space shift by what part of
By the wavelength divided by 2?
By half of a wavelength, correct?
Yeah. Okay.
So you got happen twice actually, because again it will happen at the bottom.
Yeah.
So they will cancel each other out actually.
Mm-hmm.
So your effective path length difference will be just equal to this. And now you need to choose, do you set it to minimum or the maximum?
So we set it to the minimum.
Yes, exactly.
Because it's asking us for the thinnest coating.
Okay, yeah, it says destructive anti-reflection, so 2t should be equal to the number of halves of a wavelength in the film, or, well, I don't know what specific expression do you use. This is what I usually use, one or another.
Yeah, I used the second one. Okay, I see my mistake now.
And
I
this
should use the wavelength of the film.
Okay. Yeah, but that should be in the film, so that should be the wavelength in the vacuum divided by n2.
Mm-hmm.
All right. And what are you looking for? Thinnest. Okay. T. You're looking for the smallest value of t, right?
Yes.
So 2m minus 1 over
4.
4 times, do you have 500 nanometers?
I have 550 nanometers. So,
150 nanometers over 1.38. That's supposed to be your answer. Of course, m equals 0 doesn't work, so m equals 1 works. 550 over 4 times 1.38. That should be the answer.
okay, yeah, I understand now. Yeah, thank you very much.
Yeah, no problem.
All right, bye. Have a good.
Okay, bye.
Bye.
Well, technically that's 99.64. Not exactly 100. All right.